Here I'm looking at the solution to Fitzpatrick extension 2 exercise 8.1 question 4, and I'm really interested in part B because there's an issue with the solutions at the back of the textbook. Now in part A, the question asks for us to prove that the quadrilateral POYM and the quadrilateral PXNO are cyclic. And in the process of proving that, we need to point out that we find this angle is a right angle. So, or we state that that angle OPM is a right angle. Okay, so we use this idea in part A to prove the requirement in part B. I'm just going to erase this. All right. So the questions told us that PA is the same length as PB, and it wants us to show that MA is the same length as BN. And the key to this is to show that this is an isosceles triangle, and because this is a perpendicular it's perpendicular, and if this is an isosceles triangle, then because this line is perpendicular to MN, OP is perpendicular to MN, if triangle MNO is isosceles, then it will become the perpendicular bisector. And if it's a perpendicular bisector, then MP equals PN, which means MA must be equal to BN. All right, so we start by labeling this angle alpha. Then we use the part A solution or part A reasoning. Since OY, just OY, MP lie on the same circle, then angle PMO and PYO must be equal, angle in the same segment or whatever, have a statement you want to use to explain that. So they're both alpha. Now if I construct OX, then OY and OX are radii. So OYX is an isosceles triangle, which makes this angle alpha as well. That's angle OXY or OXP. And again, from part A, since P, X, N, O lie on the same circle, the angle PXO must equal to angle PNO. So that must be alpha. So now I have my triangle OMN, and I have alpha, alpha, which makes the triangle isosceles, which makes the perpendicular from angle O to MN perpendicular bisector. And that's the reasoning to prove the requirement in part B.